Working remotely completely changed my life. Now I have time, energy, and freedom to enjoy the things I love. That's why I created a free training showing the exact steps I use to attract remote opportunities. Check the link below and get free access right now. Alright, just created a functions.py file here for us to demonstrate how functions work. Alright, so the functions are basically the smallest unit of reusable code that you can write. So instead of writing line by line and then running your file, characterizing a script, now you're going to make a transition to your code look like a software, not a script. So let's use a situation where we need to calculate the total price of a product. Basically, the product has a price, and this product based on the value must have an addition of a tax. We would create a variable called product name, and this product name would be iPhone. Product price 20,000 BRL, that is my currency here in Brazil. And the tax that we can put as known, and we can put some conditions here to assign the tax value. So if product price is greater than 10,000, tax is going to be 5%, right? 0.05 is 5%. Else tax is going to be 2%, right? Pretty simple, just for demonstration purposes. So we have the tax, and this tax right here can have a value based on the price of the product. So now we can calculate the final price, right? So final price, total price is better, is going to be the product price plus, between parentheses, product price times tax, right? Let's change the name of the variables because, to be honest, we are talking about the total price of a product, so we don't need to put the name of the variable in the name of the variable the word product, right? Our context already tells us that this is about the total price of the product. Okay, and we can make this clear in the messages that we're gonna print. Alright, so this code right here basically calculates, and we can print total price. So this script basically calculates the total price of the product and prints for us to see. Let's run. And there you go. We have the final price, the total price. So here comes the problem. Basically, this script, if the store that is selling this iPhone needed to calculate the total price of all of its products, and they are many ones, they basically have 1,000 products with different prices. This script right here is not a good solution for this scenario, right? Because someone we'll need to change the name and the price and run every time as a calculator. But this is not a calculator, this is a software, or at least we are trying to make this a software. So we need to evolve this script level code to software level code. The first thing we do is creating the functions that are the smallest unit of reusable code that we can write. So functions basically work like this. Instead of writing your code in the Python file directly, first you declare a name to this function, and then you write the logic inside of the function. Like this: def calculate total price, open close parenthesis, and column. That's how you declare a function. Pretty simple. So you use the keyword def, you give it a name, and this name must represent the logic that is inside of it is doing, right? You open and close parentheses and put a column. Everything you do inside of this function is going to be executed when you call the function, right? So let's put all of this code right here inside of the function. Pressing tab, right? So now we have the function calculate total price, and all of this is going to be executed when this function is called. And to prove this, I'm going to run the file now, and you're going to see that nothing happens. Nothing happens because we just created the function, and even if we put all of our code inside of this function, if we don't call it, it's not gonna run. Alright, in order to run, we need to call the function, we need to invoke the function. To do that, we simply put the name of the function like this. Visual Code already suggests the name because it recognizes that in this file we have a function that is called calculate total, and it recognizes the similarity of the name, right? So we can just click and open and close parentheses, okay? Not just the name with opening and closing parentheses. Now if I run, now it prints the final value. So again, if I only declare and create the function, if I run the file, nothing happens. But if I call the function with the name, like this, and run my file, it is going to run because the function is being called, is being invoked. But we still didn't achieve the best form of our reusable code, because you can see that basically we are putting the logic inside of a function, the same script logic inside of a function. We only took one step of improvement because we created the function, we encapsulated the logic inside of the function, and we invoked the function. We have run this logic using a reusable code, and this is one step of improvement, because now all the way across my software, my application, if I call this function, this block of code is going to be executed. I don't need to rewrite it all across my application, okay? But still we don't have the best form because we are hard coding some data here. We call the function, and inside of the function we are not exactly calculating the total price. We are still calculating the total price of the iPhone that costs 20 kBRL. This function only serves to calculate the iPhone tax, and this specific iPhone here that costs this value. Do you agree? But how can we improve this? How can we make this function more reusable, you know, in a way that when we call the function, we tell the function the product and the price that we need the function to calculate the total price. In order to do this, we use parameters. So let's get rid of all of this, and you see that our variable price here is already marked as red, like something is wrong, right? Because how can this decision structure use the price if we don't have the price anymore? How can this formula that calculates the percentage that must be added into the price to generate the total price, how can it calculate if it doesn't have the price anymore? So here is when the parameters comes in. The parameters are basically variables that our functions can expect. In this case, for example, in order to calculate total price to work properly, it needs the price, right? So between the parentheses of the declaration of the function, we can add a parameter that is basically a variable, right? So you can call it price. What does this function need in order to the logic that it's inside work? What is the external data that those who call the function must inform? The price, right? I'm telling basically this function, calculate the total price, but based on which price? This is what the function expects. So we can put here inside of the parentheses, and this is basically going to work as a variable, right? A local variable and a temporary variable to this function. So if I pass the price as a parameter, all of this code is going to be executed using the data that those who call this function are going to pass as a parameter. In this case, so let's see what happens now. Same thing, now it works. If I try to run this function without passing the parameter, we have a type error, missing one required positional argument, that is the price, right? So you already know how the exceptions work. You know that if someone calls this function without passing the price, it is going to break the execution, returning the type error. You can handle the exception inside of the function, and don't allow anyone to call this function without passing the price. Right, so let me put the price again. Let's see what happens. It has added 600 BRL into the price. But now let's change this value. Let's pass a value that is less than 10,000. Let's pass 9,000 and see what happens. We can see that the increment is different because of this dynamic here. So can you see how beautiful our code is becoming? Now, all across our application, everyone that needs calculate a total price using these business rules, of course, can just call this function passing the price. But there's still one missing thing that you need to know. When we write functions, our goal is to make this block of code reusable for any part of our application, any part of our software. And we need to think what those who are calling want in return. You might be probably thinking, of course, they are waiting for the calculate total price function returns the total price, right? Yes, but we are not returning. We are not returning the total price here. We are printing the total price. You can see it like this. If I print this, basically I'm telling Python, print the return of this function. Print what this function is going to return for me, right? So let's see what's going to be printed. None. You can see that the value is here because we have this print inside of the function. So it executes this code, prints in the console, but the calling of the function is printing none. Why is that? Because we are printing, we are not returning. And we are used to print because we need to see what we are doing during our development sessions, right? So we got used to print in the console for us to see. But this is not a return. Even if you are seeing with your eyes in the console, is not a return. A return must be like this: return total price, using this keyword right here. So most functions have the return as the final line, right? Because you do all you need to do and then you return the result for those who called the function. So in this case, I'm calling the function right here, and now you're gonna see that it's not known anymore, because this line of code right here is basically telling Python, print the result of this function, print the return of this function, print the data that this function returned after finishing its execution. You know, if I get rid of this print that is inside of the calculate total price function, you're gonna see that it only appears once. And even better, if I get rid of all of the prints, you are not gonna see nothing printed in my console. But that doesn't mean that it didn't return. It returned, but we didn't do nothing with this return. So if I create a variable here like total price receives the data that the function calculate total price is going to return, and then I print this data right here, now you're gonna see that it appears again. You know, you can debug all of this and see the execution line by line for you to understand how the functions work, right? But this is basically how they work. So you define a name for the function using the def keyword. If this function expects some data to be passed in order to use inside of its logic, you must add as a parameter here. You perform your logic normally as you did in the script mode, but now inside of the function and only with what really needs to be inside of this function. And in the end, you return the final data. But remember, if you only do this, you are going to create a function but never call. You are going to get your function ready to be called but still not called. That's why in the same file here we called in many different ways in order to see how it worked. So we called only the function and we didn't see nothing. We printed the calling of the function and we saw the final data printed in our console, and we called assigning the calling to a variable because the data that's being returned goes to the variable, and then we have printed the variable. Just for the record, you don't need to do this. Right? I just did the calling in the same file for you to see the function calling working. But we could write 100 functions in this file and never call them here, and only organizing the blocks of code inside of functions to be called by other file. That is something that you're gonna see in the next topic. Working remotely completely changed my life. Now I have time, energy, and freedom to enjoy the things I love. That's why I created a free training showing the exact steps I use to attract remote opportunities. Check the link below and get free access right now.